about solving simultaneous equations graphically. This is obviously the word graphically means we're going to do it with graphs. There are other ways to solve it, but today we're going to focus exclusively on graphs. My hastily drawn little picture there is showing us basically what we're looking for, and this is going to kind of build on the drawing graph skills that we used in the previous couple of lessons. So let's jump straight in. Let's jump actually straight to the end. Basically what we're looking for by the end of each question is something that looks like this. We're going to have two lines. You can see that we found the lines by plotting points, and ultimately highlighted in yellow there, we're looking for where they cross. Okay, so this here is essentially the answer. It's obviously the intersection where the two lines cross. This intersection gives a value. Okay, so this intersection here we can see is 8 and negative 2.4. So once we know that this is a value here, then this tells me that they cross when x is 8 and y is negative 2.4. Why do we say that therefore this here is the solution? Well, if we substitute those values back into the equations, what it means is that when we use x as 8, y will be negative 2.4 for both equations. It's the only time when the same values of x and y will work for both of them. If we were to pick, let's say, point B, then that tells us that for the top line, when when x is 5, y is 0. But when we look at the line underneath, okay, we can see when x is 5 for the second line, well, y is not going to be that. Y is going to be negative, around negative 1.2. So we can see that there's an example of when x is 5, we get two different solutions. But where they cross is the only time where they're both the same. So we call this the solution, and it's the solution in what we call a simultaneous equation. Simultaneous, of course, means two things that happen at the same time. So here we're saying this is the solution because it's where x is 8 and y is negative 2.4 for two equations at the same time. And that's why we say we've solved the equation, because we found when the x and y values are the same for both. So how do we go about doing that? Well, let's just look at a nice example to start off with. We've got 4x plus 5y is 20 and 10y plus 4x is 8. Now these graphs are slightly different to the ones we've been doing in previous lessons, where we've been doing y equals mx plus c. And one way to solve them is that you could rearrange them and make them y the subject and solve as we've been doing. But there is a more straightforward way that we can do this. What we can do is say, okay, let's take the first equation, 4x plus 5y is 20. And what that means is that we can split them up into a 4x and a 5y and say, well, what if we had no x's and no y's? What would be the value of the other letter? And what we can do is we can create ourselves a simple table. And this is pretty much the same table for every question. I'll show you some exceptions in a minute. We could say, well, let's find two coordinates, nice easy ones, so we can join them together for a straight line. More specifically, let's find the x and y intercepts. We know that when we're on the y-axis, x has to be 0. There is no x. The value of x is 0. Similarly, when we're on the x-axis, we know that the value of y must be 0. In terms of how we can calculate that, well, if we think about this first one here, when x is 0, we're saying, well, 4 times 0 plus 5y is 20. 4 zeros are nothing, so we can essentially ignore the x and think of it as just, well, what's 5y? If 5y is 20, well, y would be equal to 4. So we get a value of 4. And then we can plot that on the graph. Oh, do it better than that. There we go. We can do the same thing, but this time, of course, we can say, what about if y is 0? So we say, okay, well here we're going to say it's going to be 4x plus 5 times 0 is 20. And of course, 5 times 0 is nothing. So it's just going to be 4x is 20. So again, we're ignoring the y's. X is 5. X is 5, y is 0. And once we've got those 2 points, and again, this is where hopefully my iPad will behave itself. The straight line function is pretty bad. We can join those together in a straight line. Something like this. Oh, that's not too bad. Kind of worked. So now we've done the first line. So intercepts, as you can see, make it quite straightforward. We'll try the same thing for the other one. 10y plus 4x is equal to 8. Again, we can draw this as a little table. Oh, he's put an extra box. Ooh. X on the top, y on the bottom. Now, if x is 0 and y is 0, again, we can try them. We'll start off with y is 0. If y is 0, we ignore the x's. We're saying 4x is 8, x is equal to 2. Now, when we try this one here, we'd end up getting 10y, ignore the x's, because obviously 4 times 0, which we can ignore, is equal to 8. So if 10y is equal to 8, then y would equal 0.8. Which is fine, and that's okay, and we could try and plot that. But when I look at my scale, it only goes up in single units, so I know that that's going to be a bit difficult to plot. So what you can do is say, okay, well, using a little bit of mental maths, what numbers might give me whole number solutions? So I might say, okay, well, I know that if y is 2, let's say, then that would give me 10 times 2 plus 4x is equal to 8. So 20 plus something is 8. So 4x would be negative 12, and x would be negative 3. And I think, okay, well, I could have done the 0 and 0.8, but it'd be easier for me to plot a whole number value. So I've just chosen values that I know will give me a whole number solution. Negative 3, positive 2, 2 and 0. And again, 0, negative 0.8, it would go somewhere there, but it's not very easy to plot. But I've now got my 2 points, and I join these together in a straight line. Now, I know some of you will be thinking, but Mr. Donahue, didn't you say before that we have to do 3 points? And normally, yes, that is true. We would normally aim for 3 points. But sometimes it's kind of okay to use 2 as long as you're accurate. Okay, now this isn't going very well because my straight lines are not the best on the iPad. Oof. I know where it should end up, so I'm trying to get it to go there. But we'll just kind of go with it. Okay, so we do something like this, and it should have crossed, as you can see. Hopefully what you've noticed is it's meant to be this graph here with these values here. So it's kind of not gone so well because of my terrible straight line function, but it should have looked like this one here, which is the one we did before, and it gives you that solution there. So here's one I made earlier that looks a lot more accurate. All right, so let's try another one. Now you'll notice these ones here, I've picked a slightly harder one. When we do the 3x and, oh, terrible straight line ones. When we try and do the first one, when we do the little table for the first one, 3x plus y is 8. We do 4, because we need 4. We do x, we do y, 0 and 0. When x is 0, y is 8. That one works because 3 times 0 plus 8 is 8. We can plot that one, 0, 8 on the graph. However, when y is 0, that would give us 8 over 3, which is not an easy one to plot. So again, I think, okay, well, let's try if x is 1. That would give me 3 times 1 is 3. I need 5 more. And then, or I could have used, let's say, x is 2, and y would be 2. So I've got a couple of options there by some substitution. So I could do 1, 5. I could do 2, 2. And then I would join these together in a straight line. See if I can hit them all in the first go. Oh, that's not too bad. I do the second one. Again, I do my x. Oh, weird x. Don't like that one. I do my x. I do my y. Use my ruler tool, because I love the ruler tool. I try some points. I try, well, what if x is 0? Well, that would give me 27 over 5. It's not the best. I could try if y was 0, that would give me 27 over 2. Oof, also a bit, So again, I think, okay, I'll do a bit of mental maths. Well, I know that, what about if x is 1? 2 times 1 would be 2. I'd need 25 more. 5 times 5, 1, 5. That one works. 1, 5. Oh, no, that's actually worked. But let's just do one just for argument's sake. Let's try if x was, I don't know. Let's try And then you have to do a little bit of mental maths. Think, oof, well, I know if x is 4, that's not going to work. If x is 3, oh, 3 would give me, if y was 3, that would give me 15, and 15 plus 12, which would be x is 6. So I could say 6, 3. I've got my second point, and I join them together in a straight line. Your straight lines, of course, will be much better than mine, but you get something like that. Again, we can see we've got our solution here. What's the solution to this equation? Well, we can see that x is 1 and y is 5. We could have also given it as a coordinate 1, 5. We could try substitution to check that works. If you think about the first one, we know that if 3 times 1 plus 5 is 8, and we've kind of already done it, but if we hadn't, and 2 times 1 plus 5 times 5 is 27. So we can see that it works for both equations. Okay, and one more. You may see equation graphs which are a mixture of our y equals mx plus c, like the first one in green, and the red one, which is 6x plus 4y is 36. Again, we can do this via our table of values. We can see pretty early on that if we think about the first graph, it's probably not going to work for any of the values being 0, apart from when x is 0. So we could try, well, x is 0, that would give us y is 11, because that would be the intercept. So that's, obviously I can't plot it, I just realised my scale doesn't go up to it, but don't worry. If it doesn't fit on your scale, then obviously you need to find one that does. So what about if x was, let's say if x was 1, y would be 9. So I know that one will fit on my scale, plot the point. I could try if x is 2, y would be 7. And if x was 3, y would be 5. So sometimes it won't fit with your, sometimes it won't always work with your intercepts. So it's only like a sometimes solution, but it's a good thing to try. Second graph, the one in red, let's draw a little table. Again, notice I'm just quickly sketching those tables. They don't have to be super amazing. Let's try if x was 0, well, y would be 9. And if y was 0, x would be 6. And that's a nice quick one. So that's given us 2 nice easy points. We've got 0, 9. And we've got 6, 0. So that one's worked out quite nicely. Now, notice I didn't draw the lines as I was going along. I'm lucky that I can color code them. But if you had those all in the same color, it might be quite confusing. So do get in the habit, if you can, of drawing the lines as you go along. That was not straight. Let's try that one. Okay, and let's try a red one. Now, what you'll notice here, when we look at the intersection, not interception, that's not a word that we want. You'll notice it's kind of crossing in the middle of a box. Okay, so sometimes when we're doing it with a graph, we have to estimate. I would say that's kind of in the middle of the box. So I'm going to say it's crossing at 3.5, 3.5. If you wanted to check, you could just substitute into one of your equations. So you could say, what about if 3 does 3.5, let's say equal -2 times 3.5 plus 11. And we could say, well, 3.5, it would equal -7 plus 11. Well, that would actually give us -4. So I think, okay, maybe I need to go back to the drawing board there and be a little bit more accurate and check that one a bit more carefully. So as you can see, my lines are not super accurate. So what I'd recommend here is if you, well, hey, how about you pause the video and draw the graphs yourself a bit more accurately than mine and see what you get, and then we can talk about the solution. So pause the video, have a go at this, and then I will share the answer to this last one in the comments box so you can check it. Okay, so check the comments box if you haven't already. And just to summarize, draw your equations. You're finding an intersection. Try and be as accurate as this one. Do it with your table of values. Try x is 0 and y. Oh, sorry, that should have been a highlighter. X is 0 and y is 0. And if that doesn't work, choose a point that will work. Have a go at this, solving graphically, and see how it goes.